All right, cool. 932, beautiful array. For some fixed n, an array is beautiful if it's a permutation of the, the integers such that, or from 1 to n, such that for every I is less than j, there are no k with k in between I and j, such that a sub k times 2 is equal to a sub I plus a sub j. Given n, return any beautiful array A. It is guaranteed that one exists. Okay, I mean, this is a straightforward explanation. I just don't have to read this for a second. So given two numbers, there's no number in between such that it is the sum. Okay, so within these two numbers, there's no 6. Within 2 and 3, there's no 5. Okay. Um, and I think kind of, I was going to say, okay. What if I put 4 here? Couldn't you just do, I mean, my first thought is just, can you do something like oscillating, like start from the middle and then put a number in between the beginning and then the end, because um, oh, it's 2 times the sum. Sorry, because if you have a straight number array, then that will actually always be true. Well, except for if you have like 2 numbers, uh, but if you have like this, what if you have like what? Why is this? Is 213 not good? I don't know if they also just try to do, because there are multiple beautiful arrays. Sometimes they will give you an input or like an output that like is technically true but doesn't isn't the easy way to solve the problem. If it makes sense. Like I'm trying to figure out my way is um, like if I just go diagonal 1, 2, 3, and then 4 and then 5. Is this number good? Uh, no, because 5 and 1. Okay, so what I said is not, you can't do it that way. Huh. Okay, so at least there's no, I don't have the immediate solution, but can you do it the other way where maybe it's 2, 1? Why is this the case? Can you, is the next number 6, 5? Can you do that? 7 to 8? Oh no, because then the 4 is here. Other way is just, like, is there any, so we do have enough, so n is 1,000, right? So we have enough time for an n square algorithm, which means we could test an insertion. Right? So let's just say we start from the scratch, and it's always 1, 2, because otherwise you just invert it. Okay, you put it to 3. Can you put it in the front? And then you check. Now that would be n cubed if I do this operation, but let's just kind of use it as an exercise and see if I could think about it. So you could definitely put it in the front, but you cannot put it in the back, right? Because if you put it in the back, then 1 times, 1 plus 3 is 4, which is equals to 2 times 2. Okay. So this has to, by almost definition, this has to be one of the, like, I mean, like, almost like these are invariants that, I mean, this or its inverse has to be in the final way in some way. And then now you have a 4. Well, like we said before, you can't do 3, 1, 2 because Okay, so we just have to. So 4. What happens when we try to insert 4? Uh, well, all the numbers that are smaller than 4. Uh, so all the even numbers, because 4 is an even number. Um, so you know that it has to be. Mm, can 4 be here? I think so, right? Because it only matches up, which this is the only possible. I mean, there could be pretty much anywhere except for after, before 3. Okay. Uh, because it only matches with 2, so it just has to be next to 2, I guess. Um, and then now 5. What happens when you insert 5? Okay. So this one, it matches with odd numbers. So we could actually just put it on the 315, because if you're next to the smallest number on the odd, then that's fine, right? This is okay, right? Because just by, or this part is, because if you put in the middle, then it is true by definition. That I'm trying to explain. My thing is, if you put next to the 1, and you, okay. I don't think I'm articulating it well. Sorry, I'm just thinking how to kind of do it step by step. And then 6, well, you know that it matches all these even numbers. So can we just put it here? Yeah, and then now 7. How do we put 7? So 7 also matches all these stuff. All the odd numbers. So something like this. So that all the, now you can, because 5 is here. Okay, so you need the other side of 5. Is that good enough? But now I don't have it like I get an idea of how to do it, maybe. Because we could just keep apart the even and the odds. Um, but is there like a recursion thing? All right, let me do an 8. What do I do with 8? Well, let me just do this. Because we don't even have to look at the odd side now anymore, right? Let's say our thing is right. Because now you can't do this because 8 plus 4 is 12. So, and you do on this side. I'm going to even say, so let's say we have 10. 8 plus 6 is 14, so okay. I think I get why, at least on the even side. Oh no, because this doesn't work, because 10 plus 2 is 12. And you can you do it here? No, because then you have 18, so okay. You have 16, which is double, so you have to do something like this at least. um, I think I'm just trying to figure out pattern. I mean, I think so. One pattern is that we could separate the evens and the odds. But I think on both sides there's like there's a sort of pattern, but I'm not really describing that way. But okay, and maybe there's like some recursive thing. Okay, let's just think. Where am I putting 12? Um, I put it here. Is that good? Well, 16. So now, so it has to. Is this good enough? Hmm. Okay, let's try 14. This is very. Actually, I think. I mean, I've been playing around with kind of what obviously you see me playing around with kind of this. I think for me, the next step for doing this is actually try to write a brute force algorithm that I know that will not run in time because it's going to be n cube, and then try to figure out like the pattern from that, and then see if we could optimize like an n performance away. So let me at least play around the even numbers because I think odds are probably the same-ish. Maybe I'm wrong, or maybe I'll just print it out. Okay. I really have no idea how. I mean, I think maybe there's some like mathematical thing that if you're really good at math, you could figure out immediately like how the numbers are related in a way, and there's like some really crazy math proof. And also, if you're watching this for the interview, you're probably not gonna see this on the interview unless you're doing some quant stuff, or I don't know, or you're like usually say, unless your interview hates you or have a bad day and didn't have coffee or something, then like, well, sometimes you can't really do anything about it and just go home and sleep early or something. But yeah, for now, I'm gonna try to try to think, and maybe I see, and maybe this is obvious, and I just don't know. But so I'm gonna do something that works for small ends only because they have to. So okay, let's do the greedy thing of picking the first place to insert it. So okay. How do I want it? I'll just code it very lazily actually. Um, okay. Yeah, okay. No. I'm just bad at always using X for everything. Should have used I. Okay, fine. Yeah, I want it here actually. And also, if you're good at Python, please tell me how to write these things better. I'm still learning a little bit, especially Python 3. So, okay, now we just check. Let's print current, and then at the end, okay. Okay, fine. J. I guess I plus 1. Yep. Could also actually improve this a lot with like lookup tables. I'm just really writing really dumb right now, but this is like n to the 5th or some shit. So it's not great. Okay, but that's okay, let's just return something. But let's see if this gives me any insight. Okay, let's just do 10. Okay, would be nice if you actually show me. Okay, well, knew it was going to be wrong, but do I not insert it? Also, if I was in the competition, I probably would skip ahead a little bit. No. Well, take a look at the hard end and see if I could solve that one quicker. Sometimes you can, sometimes not, depending on what the contest gods feel like that day. Okay. What is it? Why is this expected? Oh, well, okay, it's good to know that I needed a plus up by 1, but so one thing to note is that you can't go the wrong way in this, in the sense that there will always be an answer. Seems like, or sorry, I mean that one just they say is guaranteed, but also that you can always build an answer from a previous answer, right? Which is not necessarily something that I would say is a given, but because sometimes I can imagine like, okay, just mess this up and then this actually like changes, right? In this case, it's okay. Let's see. I'm just curious about running time. I don't think this will run. I mean, okay. I don't know why I'm testing it then. I don't think it's gonna run. Okay. I thought at least it would give me partial progress, but okay. Let's look at the first 50 of these, and then I gotta see my pattern. I think actually I should have looked at it before, but I was just kind of doing the bigger number for fun. Okay. I would like to drag this up, but okay. Huh, I do get a wrong answer though. Is that possible? So maybe I'm wrong actually. When what I said earlier, in that and that's why I said you can make the assumption, because I think it's just not returning 50 elements, which means it breaks down at something. So that means we can't do a greedy thing where you take the first place that you could put it, because for some numbers you can't put it. But I don't want to necessarily look at their answer, because I feel like that's a little too much cheating. But let's see if I can figure out a pattern for the first, especially, I mean, because a lot of this particular problem is pattern finding, and I don't want to look at their answers for pattern matching, because that's, usually sometimes like it is an edge case and I don't feel so bad, but in this case, literally, or this problem is just trying to figure out pattern where it's, oh, whoops, I kept it at 50. It's fine. Let me just look at the top 10. So we know that this algorithm is wrong though, so like I don't know how much stick we could put in this, but maybe we could see some general pattern. And in this case, they don't separate the even and the odds, which I advocate. I think there's no reason for you to keep the evens and the odds in a good place, but maybe by that logic you could. I wonder if it's almost like if you look at the binary bits, okay, like first you separate the odds and the evens, and then you divide everything by 2, and then you separate those by odds and evens and so forth. So like almost like we construct this bit by bit, because what does it mean for two? Maybe that's an interesting way of thinking about it, right? Which is that given two numbers, binary numbers, or binary representation of these numbers, what does it mean when there's a number in between that you can't fit, right? That means, for example, 1 and 3, that means, and we want the number 2 in there, right? So 1, 0 should not be in between. And then maybe we could do some partitioning based on that. Because then we want to first match order like, is it sufficient to just first take the first lower bit and then put them together and then do the same for the upper bits? Because then basically all the zeros are all together, so in theory they can come together to make a 1. I don't know if that makes sense. Think about this for a second. Because I think for me, what makes sense is separating the odds and the evens, right? Because then these are totally separate in that if you take a number from the left to a number and a number to the right, then they're always gonna, like, if you sum them, it's always gonna sum to odd number, and because of that case, then you don't have to worry about anything in between because you can't divide it by 2, right? Or divide by 2 doesn't give you anything. Can we reduce that even further? I guess so. Because then, let's say was it 5, 1, and 7? Oops. Well, obviously. So now, let's say we took out all the last digits. So now we have this, and we want to kind of have a way to sort these, if you will. Maybe it's another sorting problem. Maybe maybe I'm just destined for sorting today. But okay, and we want to put these in a way such that none of them are in between each other. So okay, so then we want to put all the ones together in that case, so that, and then divide again, because again what we said about the probably where because then in this case then you only have to worry about this recursively and these recursively, and there's no cross correlation or whatever, like, because yeah, okay, I think I see the pattern. I don't know if I'm making it up though, to be honest, but okay, that's so it's almost like a weird what you might call it, what's it called, radix sort? Isn't it a radix sort then? You just except for on the lower bits instead of the higher bits. Okay, let's try something like that. Okay, let me play around with that idea. Plus 1, I guess. Right, okay. Let me put this in a text file so I don't lose it necessarily, just in case. But okay. Sort by last bits and this is a stable sort. So okay. Y in range of, say, just say 32. in dot sort x is equal to x. Is that weird? Because this should only return either ones and zeros, or well, not non-zeros and zeros. 28. What did I have? 15. Okay, still the wrong answer. Oh, whoops. Well, my answer is not very good, but that's fine. Why is that though? Well, let's just try one first. Y0, 0. This is a coding part, I guess. Okay, so this did actually. Oh, because after 32, then they all get sorted, and then they all zeros, and then. But I thought that would be stable. Okay, well, maybe 32 is weird. Oh no. Okay, let's just do. Let's do 3, and then we'll see if that makes sense. What am I putting? Oh, I guess I'm just putting this. Right? Why can't I? I'm just confused. So 10 should go to 1024. So why does this give me straight numbers before? Yeah, why? Okay, let me just print out each step of the way. Because even if it's 0, it should just be 0, right? Like, why is this? Okay, this sorting, and then oh, because I don't. Okay, that's just me being dumb then. Because I don't. It doesn't keep the. I mean, it keeps the ordering in a new one, but it doesn't keep the division that we had from earlier. Whoops. Yeah. Okay. How do I do this with sorting though? Essentially, what we want is a bucket sort, right? Um. Oh yeah. How do I? Man, I don't remember how to implement a radix sort easily. Um, I guess I'll just do it manually. Let me see. Also, just trying to think if there's a way to put things. I guess I could actually create a map and then use that as a key. It is being unnecessary in how I'm constructing this, but I feel like I'm on the right path though. If not, then this is all for naught. But man, chat is very quiet today. Wake up. No, I'm just kidding. I'm a little focused anyway, but so you sort, but only given the previous. We're going to sort by that digit. Yeah, okay. Let's just do it recursively and then merge in the back. how do I do that? Okay, so for x in A, we put it on the I guess actually now that I think about it, is this just the same as reversing the bit and then sorting that? Because what I was doing is essentially literally sorting by the last bit, but if we just reverse the bits, we could sort by that. Maybe I could do that. Okay, let me try that first before I go a little crazy manually sorting stuff. Oh, and just, okay, so let's do a fixed 10. Probably could have just used a mod function, but okay, same things anyway. No, I'm so inconsistent on here. Okay, fine. Since we're doing bits, let's do it this way. I guess there's no else. This is it, except for don't know why. Okay. Yeah, okay. Now let's try for 100. I mean 1,000, because that's n. I would say fun problem, cute problem. If I got an interview, I might go on a rampage though. Okay. I mean, this should be okay. I mean, just timing, right? But I could have been faster, but that's fine. Maybe I could have. Maybe there's a smarter way to reverse the bits. Wow. Okay. How long did I spend on this one? About half an hour. Okay. I mean, definitely, possibly could have been faster. I don't know if that's a smart thing to. I mean, there are a lot of. I mean, well, one is an interview problem. This sucks. Don't worry. I mean, don't worry about it. If you see in an interview, maybe just give up. It's fine. Sometimes you're gonna get unlucky. Sometimes life is sad. But and like, there's no reason for you to kind of train for this per se, unless you've trained for everything else. Like any person, I mean, and it's very, yeah, I don't know. I mean, and you saw kind of me breaking it down a lot. I think in general, I kind of used a lot of the tools I had, but I think maybe I could have done a little bit better on. I mean, this is a fun prompt. I would say for a brain teaser trivia thing, it's fun to kind of having the ability to kind of work through this with Yao, but definitely not interview worthy maybe, or just like too weird for an interview. Actually, I think in the beginning I had this intuitive thought that I didn't follow up on until much later, which was this. Was I think like way early on, I got the idea of like, okay, let's break apart the evens and the odd numbers, and then and yeah, and I was like, can we do this like in a recursive kind of way? I didn't really follow that through enough until I guess much later, because I was trying to do maybe some sort of greedy, as you kind of saw, and also using that method to kind of generate to see if I could figure out a pattern that I could figure out. I would say, I mean, it didn't apply here, but it's definitely a technique that for a lot of problems in which it's like counting, right? Like maybe just like, you know, that like n is sometimes like 10,000 or something big that you cannot, you know, generate all of them, but just generate the first, say, like 20 numbers to kind of see if you could see a pattern, or like, you know, figure out optimize that way. Oh my gosh. I mean, this is unique for sure. Hey, poster right. But yeah, But I think even though that didn't really apply here because I couldn't really figure out a problem, and I think actually it's possible that the solution that they gave is just relatively okay. So it's not actually. I was gonna say maybe just inverted of what I have, but it's probably close. Maybe not. I don't know. Maybe there's another way to do it, to be honest. But the way I was thinking about it is okay. Now that we have this, I mean, and actually in a weird way, it's a I was going to say beautiful, but a beautiful illustration of divide and conquer, because you can actually have you could have actually now that I think about it more, but I didn't do that on the problem, is that you can actually quick sort and then divide and conquer, or just divide and conquer, and then in a way either quick sort, I guess maybe even merge sort would have been okay, because then it's like okay, separate the odds and the even, and then now look at the second bit, and then separate that recursively and so forth, right? So I could have done it that way instead of what I did here, because this took a lot of leaps in logic, which maybe is not as intuitive to me, but maybe if you're good at math, maybe that's fine. I don't know if there's maybe this was in the contest, and I wouldn't see how fast to ridiculously good people do it, and what is the average time and stuff like that, because I think that matters a little bit. But yeah, so maybe recursion. If I had thought about it a little bit earlier, maybe I could have done recursion, and that's maybe actually a very reasonable problem. It's still not, it's still a little too tricky for an interview, but yeah, but my last leap is kind of just because we want to sort by the last bits. I mean, initially I thought it was some sort of radix sort, which is still technically true, but then, but I was thinking through like the next step of that is that actually there's a very fixed order of doing it, which is you doing it from the low bits to the high bits, and in that case you just want to reverse the bits and then you could sort normally, and that's what I end up doing. Uh, and yeah, and I think for each of these, I mean, I think I kind of explained it during my thought process a little bit, and took some leaps on guessing and that it works. But basically, for every kind of recursion, you separate with the zeros and ones, because then the only way that's possible of getting a number that's equal to this in the middle is if there exists like a one and bits where there's a one and a one, and then there's a zero in the middle, right? In any given bit, recursively, but and once you kind of try to force it in a way that's not, which is that you force all the zeros and ones together, so that there's no way for all the ones to make, there's no zeros in between all the ones, and there's zeros between the zeros, but then when you sort it again, so that the recursive probability would take care of the fact that yeah, so I think that's how the way I've thought about it. I wonder if there's another way of thinking about it, because I think the result that they give is a little different, and maybe there's just some like weird things, but yeah, that's how I thought about this problem. It's a little tricky. I don't know, but I say like for those competitive programmers, the really good people get them really quickly, and they're really good at math. And I think excuse me, I think I mentioned that when I first looked at it, I was like, this is also like a problem where like someone really good at math, like really, really good at math, would get in like 3 minutes, because this code is like 5 lines of code, and I'll be like, man, I don't, this is ridiculous. But yeah, we look for the interview. I mean, and also just the complexity. I mean, this is O of n, and this is O of n, and oh, sorry, yeah. Well, this is O of n, and this is O of n, and the sorting is obviously n log n. So this is n log n with O of n space, where you can do much better than that, because that's the size of your output in terms of the space part. And you could, if you actually do, or if you if you do a counting sort type thing on the bits, then technically you could do the sorting of O of n, and obviously in this problem is what it gives way natural to that. So you could, in theory, solve this as an O of n, but actually, where n is the output size. But I would also say that in theory, and in this case, n is actually not the size of the input. N is a number that is represented by log n bits. So that is the size of the input. So for the pedantic interviewers, uh, technically this is actually will take 2 to the n space and 2 to the and and n times 2 to the n for sort if you don't do a counting sort, and 2 to the n running time, where the n is the input size and not n the number input. Some interviews are pedantic about it, so you should consider that. And the other thing that I had one more, and oh yeah, and even though 2 to the n sounds scary, it is still the output size. So you can do better than output size um, because that's the minimal size that you need to print out or return in a way of, right? So it's still optimal, despite the scary 2 to the n thing. But I think that's all I have to say about this one. Overall, a fun problem. Actually, I'm going to take a peek at the solution. Maybe there's another easier way to do this, but I thought it was a fun problem anyway, though. The answer is quite, I mean, I mentioned this, but the answer is quite intuitive. I mean, it took me half an hour to came up with it, so, but I actually mentioned this algorithm, so okay. Oh, there's only one. Why did I say approach one if there's only one approach? I was going to see if there's another approach. But yeah, and in theory, you could actually even do better. So maybe that was approach 2 that I gave, you viewers at home or wherever you are. Because technically, you could do an O of n because you can actually do counting sort once you, sorry, radix sort, which I guess is a variation of counting sort, but essentially doing that. Yeah, okay. I mean, I guess this is okay. I mean, I think that's all I have to say about this farm. Okay, I mean, I'm glad that I got this actually, and maybe even a better running time.